So parallel and perpendicular lines. Now, if I have one line and I can easily find the equation of the line that's parallel to the given line. Now, we're going to use something conceptual to recognize why the remark that I'm going to write is true. Suppose I have a line of that sort, and let's say there is some intercept -2. If I want a line that is parallel to this line, whatever line that I have must be at the same slope as the original line. You can see that the way I sketched it here, the second line that I put is parallel to the first. So the slopes are very much the same, or exactly the same. So if two lines are parallel, the slopes are the same. But their intercepts, y-intercepts to be very specific, are never the same. So the slope of the second line that is parallel to the first line will be the same, but the intercept will not be the same, the y-intercept. So for instance here, perhaps the y-intercept is 1. And you can see the two lines are parallel to each other. So parallel So I'm going to select a second line, and let's see if I put it in a different slope, if it's still parallel. So if I tilt the line a bit, let's say I'm changing the slope clearly, and if I change the slope, then naturally you can see that the slope is no longer the same, and they're not parallel to each other, and they intersect. So another way to recognize that two lines are parallel in a geometric sense is that the lines will never intersect. So parallel lines cannot intersect. You can notice different slopes and a point of intersection. So if two lines intersect, then those two lines cannot be parallel to each other. So perpendicular lines, a line is perpendicular to another line if they intersect at a right angle. They have to intersect at a right angle. So these two lines, they don't intersect at a right angle. If they intersect at a right angle, then those two lines are perpendicular to each other. What do I mean by right angle? Suppose I have that line, and I have that line. The angle that is formed right here is 90 degrees. So if that angle is 90 degrees, then the two lines are perpendicular to each other. Here, that's not the case. The angle is more than 90 degrees. So clearly, if lines are perpendicular, they definitely will intersect. They have to. And if you notice, the first line has a positive slope. And if a line has to be perpendicular, the second line here has a negative slope, or vice versa. So if two lines are perpendicular to each other, they have opposite lines. So if one line has a slope of +3, the other line would have a slope of -3. It has to. The most, I will take that back. It has to be negative, but not 3. So the most important requirement here is it will not just be negative, the slope, rather it will be the negative reciprocal of the slope of the first line. Only then you would have a 90-degree angle. So perpendicular lines, one slope, which is the negative reciprocal of the other slope. Of course, the signs differ because if one is positive, the other is negative. So one slope is the negative reciprocal of the other slope. And they can have the same Y-intercept. How so? So you can see that the second line is perpendicular to the first line, but that line has the same Y-intercept as the first line. So they can't share the same Y-intercept. So key things to note, parallel lines will have the same slope. Their Y-intercepts are never the same. The lines will never intersect. Perpendicular lines, on the other hand, will have to definitely intersect at a right angle. That's very important. At a right angle. they will have opposing signs for slope, and the slope of one is the negative reciprocal of the slope of the other, and they can't have the same y-intercept, unlike parallel lines. So here we want to consider a line that's passing through 1, 2 and 3, 1. And then we have to find the line that is parallel to the line obtained and passing through 1, 1. So the very first step is to find the equation of the line passing through that point and that point. So the equation of the line passing through 1, 2 and 3, 1 is, well, we could just find, let's just find it using slope intercept form. So m is y2 minus y1 divided by x2 minus x1. So y2 is 1, y1 is 2, x2 is 3, and x1 is 1. So 1 minus 2 is negative 1, 3 minus 1 is 2, so we have negative half. We have to find the y-intercept, so y equals mx plus b. When x is 1, y is 2, right here. So I'm going to plug in x and y. So 2 equals m times 1 plus b, but the slope is negative half. So 2 equals negative half times 1 plus b. So 2 equals negative half plus b, which would mean b is equal to 2 plus 1/2, which is 2.5 or 5/2. So the equation of the first line is y equals negative 1/2x plus 5/2. If you recall earlier, I mentioned that if you did everything right, the denominator and the slope will match up to the denominator in the y-intercept. And that seems to be true. You can either leave it as is, or you can pull a 1/2 out or negative half out. If negative half comes out of negative x/2, I'll have x. If I pull negative half out of 5/2, I'll simply have negative 5. So you can write it that way also. Now the objective is to find the line that is parallel to the line that we just found. So we want to find the line that is parallel to the above line and passing through the point 1, 1. So what do we know about this line? We'll call this line as y equals ax plus b, or ax plus c, different letters. The slope of this line must be the same as the above line, negative 1/2, because they are parallel. So the slope A has to be negative half because the lines are parallel. Now, how do we find C? We know the slope, and we know the second line passes through 1, 1. So I'm just going to take this point and plug it in. So 1 is equal to -1/2 for A multiplied by 1 plus C. So 1 is equal to -1/2 plus C. Move that -1/2 to the other side, we have +1/2. So C would be 1.5, which is 3/2. Just like the previous problem or the previous part, the slope has a 2 in the denominator. The y-intercept has a 2 in the denominator. So it is most likely that we did the problem correctly. So the equation of the line parallel to the one we found, y equals -1/2 x plus 5/2, and passing through (1, 1) is y equals ax plus c. We know the value of a. The slope has to be the same, so -1/2 plus x. And we found the value of c, which is 3/2. We can combine the numerators because we have a common denominator, so -x plus 3. And we can write it as 1/2 times -x plus 3. So I'm going to consider the previous problem that we just did, where we found a line that is parallel to the one we obtained and passing through 1, 1. This time, we're going to find the line that is perpendicular to the line we obtained and passing through 1, 1. The line that passes through 1, 2 and 3, 1 is -1/2 x plus 5/2. We did that in the previous problem. So and now we want to find a line that is perpendicular to the line that we just obtained. So and not only that, it has to pass through 1, 1. Let me just call it to be dx plus g. I just want to use different letters. Now d has to be the negative reciprocal. So the negative of -1/2 is +1/2. And it has to be the reciprocal of 1/2. In other words, we are trying to find negative of -1/1/2. Excuse me, -1/1/2. So that is the negative part, and that is the reciprocal part of the original slope. So the negatives would go away, and 1/1/2, if you flip and multiply, you simply get 2. Now, y would equal to 2x plus g, because we just computed d to be 2. So at the point 1, 1, the value of y is 1, and the value of x is 1. So 1 would equal to 2 plus g. which would imply G equals 1 minus 2. Let me not skip the step. So 1 equals 2 plus G. Subtract by 2 on both sides. 1 minus 2 is equal to G. So minus 1 would equal to G. So the line that is perpendicular and passing through 1, 1 is y equals dx plus g. We found d to be 2, which is the negative reciprocal of the original slope, which is negative half, plus g, so plus negative 1, which is simply 2x minus 1. Now, I showed you how to graph this using a TI calculator. And if you graphed it, you will see that the two lines are perpendicular to each other. And if you graphed the previous two lines that we found, you will see that the two lines are parallel to each other. I would like for you to try graphing these and verify if they're in fact parallel or perpendicular to the line that we just obtained.